Okay, in this video, I'm just going to continue on solving word problems with you in that are dealing with scientific notation. I just want to give you a quick reminder, when there's about 10 minutes left in class, you're going to need to complete your exit slips, so get as far as you can through this video, but you need to save time at the end to do those exit slips. Okay, let's take a look at question 4. A computer's hard drive holds 8.0 times 10 to the 7th bytes of information. Julia buys a memory stick that holds 3.0 times 10 to the 8th bytes of information. How much memory will the computer have altogether? Between the hard drive and the memory stick, how much now memory does that, how many bytes of information can that computer now hold altogether? Write your answer in scientific notation. Okay, I know I need my answer in scientific notation. I know the hard drive can hold 8.0 times 10 to the 7th bytes of information. I know the memory stick can hold 3.0 times 10 to the 8 bytes of information. And I want to know how much memory will the computer have all together. All together is definitely a key word. First of all, I look, and both pieces of information they give me, they're both measured in bytes. So I think, will I fall back on my proportional reasoning from last week? Probably not, because we are not dealing with two different quantities we're comparing. We're comparing the same quantity, bytes to bytes, which means it's probably going to be an addition or a subtraction problem. So then I search out my keywords. I say, oh, all together. How much memory all together? Oh, all together says I'm going to add. So I use that keyword to help me. So I'm like, okay, the answer's got to be in scientific notation. Both given items are in scientific notation. I want to know how much memory all together. I know I want to add. Okay, I'm just going to take the memory on the hard drive, which is 8.0 times 10 to the 7th bytes of information. And I'm going to add on, because I want to know all together, 3.0 times 10 to the 8th bytes of information. I'm adding, which means my exponents on the base of 10 must agree. So I say to myself, okay, I want to increase the smaller number, so I want to increase 7 up to 8. And as soon as I know I'm increasing or adding on, left add, I know I need to move that decimal point one place to the left. So it's 0.80, or just 0.8 times 10 to the 8th plus 3.0 times 10 to the 8th. Like, okay, good. My exponents on the base of 10 agree, so I know in the end it's going to be times 10 to the 8th. I know in the end it's going to be measured in bytes of information. I always want to make sure that I keep my units. Then off to the side, I can do my 3.0 plus 0.80. Of course, that's 3.8. So that's 3.8 times 10 to the 8th bytes of information. I just want to make sure, does my final answer make sense? I was adding, so it should be larger than either of the given two. Well, is 3.8 greater than 3.0 times 10 to the 8th? Yes, it is. And that was my largest number given. Remember, that number is quite a bit smaller. So I'm like, my answer probably does make some sense. So then I say to myself, I'm good to go, and I move on. Pause the video if you need. All right, let's take a look at this. The speed of light is 3 times 10 to the 8th meters per second. 3 times 10 to the 8th meters per second. Already I'm like, wait a minute, this problem might be different. I have two quantities running around. I have meters and I have seconds. The sun is approximately hundreds, thousands, millions, billions, 230 billion meters from Mars. So the sun is 230 billion meters from Mars. How many seconds does it take for sunlight to reach Mars? Write your answer in scientific notation. Okay. So the first thing I know, I'm like, hey, I'm comparing two different quantities. I probably do want to use my proportional reasoning now, because I know I'm comparing meters to seconds. So I'm going to set up a beautiful proportion, meters to seconds. When I'm comparing two different quantities, a lot of times we're like, well, the easiest way to handle that might be some proportional reasoning. The speed of light is 3 times 10 to the 8th meters per second. When it says per second, it means per 1 second. So I'm like, okay, those items are related. 3 times 10 to the 8th meters in 1 second. So I'm like, because they're related, they go on one side of the equal sign. 3 times 10 to the 8th meters in 1 second. So I'm like, okay, everything's got to be in scientific notation. So I'm going to rewrite this number of meters in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 2.3 times 10 to the 11th. So that, because it was measured in meters and we put our meters on top, that means 2.3 times 10 to the 11th goes on top. And I want to know how many seconds. So I'm like, oh, they're looking for seconds. I could call that, I'll put a big T for time, the number of seconds. Then I can simply cross multiply. 3 times 10 to the 8th times T is 3 times 10 to the 8th with a big old T. Keep my equal sign. Cross multiplying on this side. 1 times 2.3 times 10 to the 11th is still 2.3 times 10 to the 11th. Okay, I need to solve for t, so I divide both sides. I put my fraction bar down to divide both sides by whatever t had been multiplied by. Well, t was multiplied by 3 times 10 to the 8th, so I'll divide both sides by 3 times 10 to the 8th, 3 times 10 to the 8th. Now, I have to tell you, because we're dealing with division, we don't have to worry about the exponents agreeing. We just fall back on our rules for exponents. So we do t equals, we're dividing, so 2.3 divided by 3, I believe is 0.76 repeating. I don't have a calculator here at home, so I'm doing it from memory. So I'm going to just approximate that to 0.77. Little swivel equal sign means approximately. 0.77 times 10 to the, well, when I divide, what do I do with those exponents? I do 11 minus 8. So 10 to the 11 minus 8. So that is 0.77 times 10 to the 11 minus 8 is 3. Then I'm like, ooh, but this is not in scientific notation. They asked for my answer in scientific notation. This is not in scientific notation because it's a number less than 1 here, which means I need to move my decimal point here so that it will be in scientific notation. 7.7 times 10 to the, well, if I'm moving to the right, we know right, subtract, which means I'm going to subtract how many places did I move? I moved 1. That's 10 to the second. We all remember our good friend Lars. Right, subtract. If we had moved to the left, we would have added, but we did right, subtract. So there you go. And what does my answer need to be measured in? I look back, it's asking how many seconds. The variable t was next to the s for seconds, so it's that many seconds. So I'll put a little s to represent seconds. So that's the type of word problem we worked with last week. Let's try another one. The mass of one methane or natural gas molecule is 2.7 times 10 to the negative 23 grams. Okay, so the mass of one methane molecule is 2.7 times 10 to the negative 23 grams. Again, I'm like, oh, we're comparing two different items. One molecule is that many grams, molecules to grams. So before I even read on, in my mind, I'm already like, this is probably a proportional reasoning. I am comparing two different quantities, molecules to grams. Find the mass of 60,000 methane molecules. So the 16,000 is methane molecules. So the 60,000 is molecules. We know what one molecule is in grams. And they want to find the mass of 60,000 molecules of methane in grams. Write your answer in scientific notation. Okay, so first of all, I'm like, okay, well, I'm comparing two different things. I'm comparing molecules to grams. Then I look at my information. Okay, I have one methane molecule Okay, that says 1 methane molecule. So next to molecule, I put 1. How many grams is related to that? Is 2.7 times 10 to the negative 23 grams. So if it's related, it goes on the same side of the proportion. So 1 molecule is 2.7 times 10 to the negative 23 grams. They give me 60,000 molecules. Oh, 60,000 molecules. So I know that 60,000 goes with molecules. We chose to put the molecules on top, and we're looking for how many grams that is. I'll put a big old G for grams. We don't know how many grams that is. I want my answer in scientific notation. So what I'm going to do is I'm going to rewrite this 60,000 in scientific notation. 1, 2, 3, 4. So I know that that is 6 times 10 to the 4th molecules. 6 times 10 to the 4th molecules. 1 molecule is 2.7 times 10 to the negative 23 grams. 6 times 10 to the 4th molecules is how many grams? I just go ahead and I cross multiply. 2.7 times 6. 2.7 times 6. 7 times 6 is 42. 2 times 6 is 12. And 4 more is 16. I hope. Move my decimal point over 1 place. Oh, I hope I didn't make a mistake. I don't have a calculator. 16.2 times 10 to the, what do we do when we're multiplying? Oh, we add those exponents. So it's negative 23 plus 4 equals, what's 1 times G? 1 times G is just G, so that'll give me the number of grams. So that's 16.2 times 10 to the negative 23 plus 4. Use your calculators if you need. That must be negative 19. Negative 19 grams. And then I just look back and I'm like, okay, does my answer make sense? Well, 1 molecule was 2.7 times 10 to the negative 23 grams, so 60,000 molecules should be a greater number of grams. Well, is 6, ooh, I'm not done with this problem. Ooh, hopefully you noticed my issue. Is 16.2 times 10 to the negative 19th greater than 2.7 times 10 to the negative 23? Oh yes, that is a greater number. If we have more molecules, we should definitely have a greater number of grams. Negative 19 is greater than negative 23, so I'm on the right track. But hopefully you all were like shouting in your heads, not out loud in class, but in your heads, hey, she's not done. Her answer's not in scientific notation. So what do we have to do? Well, to get it in scientific notation, we know it needs to be 1.62. The number has to fall between 1 and 10 times 10 to some power grams. Then I'm looking, okay, what do I have to do? Oh, I'm moving to the left. Left, add. So negative 19 plus 1 gets us to negative 18. You make sure you are using that calculator if you're still struggling with your 7th grade skill working with integers. Negative 19, if we increase that by 1, we're moving towards 0. That gets us to a negative 18. All right. So I'm going to tell you that's all I have to say on word problems for today. So if you haven't run out of time and you're still listening to this video, you go ahead and it's time to try your exit slip and then work on tonight's assignment. I hope you were well behaved for the sub. Try to have a good day. I will see you tomorrow. Take care.